one zero is negative the other. Let's say if I take alpha and beta as the two zeros. Hello everyone and welcome to another video. In this lesson, we are going to do these questions from the chapter Polynomial class 10th. If the zeros of the quadratic polynomial x²+a+1 times x plus b are 2 and minus 3, then the values of a and b are. So in this question, we are given the two zeros as 2 and minus 3. So let's say if I take two zeros as alpha and beta and say alpha as 2 and beta as minus 3. So we have a relation that is sum of the zeros is equal to negative coefficient of x divided by coefficient of x squared. So what is alpha plus beta? This is 2 minus 3, which is minus 1 in this case, which is equal to negative coefficient of x. And what is the coefficient of x? It is a plus 1. So negative of a plus 1, that divided by coefficient of x square, and coefficient of x square is 1 in this case. So this divided by 1 is the number itself. Now check here what we can do. We can cancel this from here, and on transposing this a to the other side, it gives you a as how much? 1 minus 1, that is 0. So we got the value of a here. We got the value of a in this case. Now similarly, we are going to obtain the other value, and this time we have the product of the zeros is equal to constant term divided by coefficient of x square. So what is the product of the zeros? That is 2 multiplied by minus 3, which is minus 6 in this case. The constant term here is b, so we'll be writing b, that divided by the coefficient of x square, which is 1 in this case. So we can say that from here b comes out to be minus 6. So we had to get the value of a and b. So we'll say that a equals 0 and b equals minus 6 is the required answer. If alpha and beta are the zeros of the quadratic polynomial fx equals 3x squared minus 5x minus 2, then alpha cube plus beta cube is equal to. Now, on comparing this given polynomial with the standard form, what we can say, a, which is the coefficient of square term, which is 3 in this case, b, which is the coefficient of the linear term, that is minus 5, and c being the constant term, which is minus 2 in this case. So from here we can say that the sum of the zeros is what? Minus b over a. So minus of minus 5, that is 5 over a, which is 3, and the product of the zeros is what? C over a. So c is minus 2, so minus 2 over a, which is 3 in this case. Now once we have obtained, we are going to apply the identity, that is a plus b whole cube is what? A cube plus b cube plus 3ab bracket a plus b. So here we are going to replace this a plus b with what? Minus 5 over 3, and replacing ab with minus 2 by 3. So let's say if I replace in the first part, it is a plus b is replaced with what? 5 over 3, and there is a whole cube. Keeping this alpha cube plus beta cube as it is, as we have to determine the value of alpha cube plus beta cube. Plus this is 3 times alpha beta, and alpha beta is what? Minus 2 over 3 times the sum of the zeros, which is again, it is 5 over 3. So we can say that 1, 3 get cancelled over here. On further simplification, the cube of this result to give you how much? 125 over 3 cube is 27. And how much is this? This is minus 10 over. This is minus 10 over 3. So on transposing this to the left hand side, it should become positive 10 over 3, which is equal to alpha cube plus beta cube. So next we are going to take LCM, which is 27 in this case. This is how much? 125, and 3 how much? 9 times is 27. 9 into 10 is 90, right? Which can be written as what? 215, right? 215 over 27 is what the value of alpha cube plus beta cube. If one of the zeros of a quadratic polynomial of the form x²+ax+b is the negative of the other, then it has no linear term and constant term is negative. Option B has no linear term and the constant term positive. Option C can have a linear term but the constant term is negative. And option D is can have a linear term but the constant term is positive. Given this polynomial, since one zero is negative the other, let's say if I take alpha and beta as the two zeros, then one zero is negative the other. So can I write alpha equals negative beta? And on transposing beta to the left hand side, we can say that alpha plus beta equals 0. And what is sum of these zeros? As for the coefficient, is its negative coefficient of x divided by the coefficient of x squared. So negative coefficient of x in this case will give you minus a over coefficient of x squared, which is 1. So we can say minus a over 1 equals 0, or I can say that a equals 0. So we got the linear term here. This is the linear term as 0. Now we are going to use the other relation in this case. The other relation is what? The product of the zeros. Now what you can see that since one zero is negative the other, can I say that their product will be negative? Has to be. When two numbers are such that one is negative the other, then their product will be negative. Now, as for the coefficient, what is alpha beta? It is constant term divided by coefficient of x squared. So constant term is what? Over here as b, that is positive b divided by 1 is b only is negative. So we can say that b is, that is b is what? The constant term, and constant term is negative in this case. Are the zeros of the quadratic polynomial x square minus 6x plus a, then the value of a if 3 alpha plus 2 beta equals 20 is minus 12. Option A, true. B, false. C, can't say. D, partially true or false. Now first we are going to compare this given polynomial with the standard form. So on comparing, what do we get? We get a, b and c. And what is a, which is the coefficient of x squared, that is 1 in this case. B, which is the coefficient of x, which is minus 6, and c, that is the constant term, which is given as a. Now first we are going to obtain the sum and the product of the zeros. And what is sum of the zeros? That is taking alpha and beta as the zeros, sum of the zeros is minus b over a. So minus of minus 6 is what? 6. That divided by 1 is 6 only. And what is product of the zeros? That is c by a. And what is c in this case? That is a, and a divided by 1 is a only. Now we were given in this question, that is 3 alpha plus 2 beta equals 20. So what we are going to do is to write this 3 alpha. We are going to write this 3 alpha as alpha plus 2 alpha. And let 2 beta be as it is, equals 20. Now check, if I take alpha 2 as common, right? I can take 2 common from here. So it will give you alpha plus beta equals 20. Now this is 2 times alpha plus beta, and we have alpha plus beta as how much? 16. So 6, sorry. So 2 multiplied by 6 equals 20. So now from here we can obtain alpha, and alpha is what? 20 minus 12. That is 8. Right. We got alpha here. And now if I replace alpha in this case, right, replacing alpha in this case, we'll get beta as what? Beta will be 6 minus 8, that is minus 2. So once we get the value of alpha and beta, next what we can do is to plug in the value of alpha beta over here. So replacing alpha here with 8 and beta as minus 2 should give you the value of a. So therefore a comes to be what? Minus 16. So we'll say that the value of a is minus 16. Therefore the statement given here is false. Now comparing this given polynomial with the standard form, and what is the standard form? This is ax square plus bx plus c. From here we get a as what? Coefficient of x square, which is 1, b as negative 4, and c as 1 over here. Now we were given one of the zeros, and we know that alpha and beta are the two zeros taken. So if I take alpha as the one of the zeros, which is given as how much? 2 plus under root 3. Now we have a relation between the sum of the zeros, and that is alpha plus beta, which is sum of the zeros, is minus b over a. Now replacing this alpha with a value, we can replace alpha as what? 2 plus under root 3 plus beta is what we have to determine is equal to negative of negative 4, right? So minus of minus 4 is positive 4, that divided by 1. So any number divided by 1 is the number itself. Therefore, we can get beta as what? Beta should come as, on transposing this number to the other side, it should be minus 2 minus under root 3. So this gives beta as what? 4 minus 2, which is 2 minus under root 3. So we'll say that the other 0 is 2 minus under root 3. The zeros of a quadratic polynomial fx equals ax² plus bx plus b² minus ac times x minus
Now,
bc
in order to
are.
find the zeros, first we are going to open this bracket. So if we do so, what we are going to get here, that is, this is ab times x square. On opening this bracket, x will be multiplied with each term. So that results to give you how much? B square times x minus ac times x minus bc. Now you can check from here, we can take out common, and what is coming common here is bx is coming common. So on taking bx as common, we get how much? A times x plus b. And similarly from here, taking negative c as common, we get what? We get ax plus b. And y plus, because we have taken minus common here. Now throughout we can see that ax plus b is common. So therefore we are going to take ax plus b as common, and that multiplied by bx minus c. Now comparing this with 0, we are going to get x as what? Minus b over a. And comparing this with 0, we are going to get x as what? C over b. So we'll say these are the two zeros of the polynomial.
Alpha and beta of a polynomial x² minus 7x plus k are such that alpha minus beta equals 1, then the value of k is.
So first we are going to compare this polynomial with the standard form of quadratic polynomial, that is ax² plus bx plus c. So on comparing, what do we get? We get a as coefficient of x², that is 1, b as the coefficient of x, which is 7, and c being the constant term, which is k in this case. Now, first we will obtain sum of the zeros. And what is sum of the zeros? This is minus b over a. So we can say sum of the zeros, that is alpha plus beta, should result to give you minus of minus 7 is what? Positive 7 over a, which is 1, which is 7 over 1 is 7 only. And we are given that alpha minus beta is equal to 1. Say this is equation 2. Now on adding these two equations, if I add these two equations, you can see beta and negative beta get cancelled. So now alpha plus alpha is what? 2 times alpha, and 7 plus 1 is 8. So alpha comes out to be 8 divided by 2, that is 4. Now once we get the value of alpha, we can place in the equation 1, right, to obtain beta. So if I replace alpha in this equation, that is alpha plus beta is 7. Replacing alpha with 4, we get beta as what? 7 minus 4, that is 3. Now check, we got the values of alpha and beta, but then we had to get the value of k. For that, we are going to use the other relation, that is the product of the zeros. So what is product of the zeros? Product of the zeros by actual multiplication, these are the zeros, right? B alpha is 4 and beta is 3. So 4 into 3, that is 12. I should show it 4 into 3. So we get product of the zeros as how much? 12. Further, using the coefficients, you can see that product of the zeros is what? C over A. This is what? The formula for the relation between the zeros. So we know that the product of the zeros is what? C over A. Now using this relation, we can say that C is what in this case? C is K. So K over 1 is K only. Now let's compare these two. We know that alpha into beta is 12 and alpha beta is k. So we can compare these two and say that k is equal to what?
12. Right. So since alpha beta is 12 and alpha beta is k here, so therefore equating these two we get k as 12.